Okay, here's our first example. Now this is a degenerate conic. Now whenever you get this on the test and you look at it, you're not going to really know if it's a degenerate conic. In fact, if you look at this and see the same positive value in front of your x squared and your y squared, you would probably suspect that it would be a circle, or you should suspect it's going to be a circle. But let's just complete the square. Really the procedure is the same whether it's a circle, an ellipse, or a hyperbola. Let's collect our x's together, leave a space, collect our y's together, leave a space, and move the 29 over. Complete the square. Half of 10 is 5. 5 squared is 25. Add 25 to both sides. Half of 4 is 2. 2 squared is 4. Add 4 to both sides. And hopefully you can kind of see, right away, that something weird is going on. Because right here, I had a negative 29, and now I have a negative 29 plus 29 that goes exactly to 0. Now, it kind of looks like a circle, or it kind of looks like an ellipse, but if it's a circle, that would be the radius squared, and if it's an ellipse, then you need to get this thing to 1. Well, you can't get it to 1, because you can't make it a 1 by dividing by anything, so it's not an ellipse. And I guess the best way to look at it is it's like a circle with a radius of 0. And I guess a circle with a radius of 0 would be a circle that collapses to a point. Another way to look at this is, or, if it's a circle, with a center, with a radius of 0, then where's the center? But another way to look at it is simply, what is the solution to this thing? How can you take something squared plus something squared to get 0? And if these are non-zero numbers, you can't do it. If this is non-zero and this is non-zero, when you square them, it'll be positive. It won't give you 0. The only solution to this is whenever x is exactly equal to 5 and when y is exactly equal to 2. So if this was a circle, the center, or an ellipse or anything, the center would be at 5, negative 2. And that point is the only solution to this equation. So the graph of it is over 5, down 2. The graph of this thing is just a single point. The only point in space in the coordinate plane that satisfies this equation is this point. So there's our degenerate conic. How do you know when it happens? When you get a 0 on the other side. You can't make it an ellipse or anything else. Okay? Pretty easy, but that's it.